All right, like terms are terms whose variables and exponents are the same. Write that in the spot next to where it says problem number 1. This expression, 5x squared plus 3x squared plus 4x plus 3 plus 2x, taking this logic right here with what we know about like terms and that we can only add like terms, is going to simplify to 8x squared from this plus 6x plus 3. You can think about why that is, why that makes sense, and throughout today's lesson, we're going to build that understanding of why this is our end product. Now from here, I know that like terms are terms whose variables and also exponents are the same. Here, I have 8x squared plus 6x plus 3. Now, even though I have x in both of those, I have the same variables, I also have to have the exponents on those variables the same. So, here I have a 2 on my x squared. Here I have x to the invisible first power. My exponents are not the same here, so right here is as simple as we can go. We can't add anything else as our final answer. So here are today's objectives. So here we've done this before. I'm going to just click through this really fast, and you can just fill in these tables. Remember that 0 when we're doing repeated addition, 0 is our starting point. And when we're doing repeated multiplication, we have 1 as our starting point because 1 times any number gets you itself, just like 0 plus any number gets you that number. So x to the 0 is 1, x to the first is 1 times one set of x, and so on and so forth. So pause the video, make sure that you have both of those tables completed. Same thing with numbers. 3 times 0, expanded form, starting point plus no 3's. We don't have any 3's being added to that 0. Starting point plus 1 set of 3. So go ahead and get that copied down. And then for the exponents, three to the 0th power, just like x to the 0th power is 1, any number raised to the power of 0 is 1, so 1, my starting point. 3 to the first is my starting point times 1 set of 3. 3 cubed is 1 times 2 sets of 3. Make sure you have those tables figured out. Think about what those are. This is review. That's why we're going through it fast. So if you have any questions, come and see me. Problem 2. Write this down in the spot in your notes for problem 2. X plus 2x and x plus x squared. What we're going to do with this part of the notes is we're going to look at both of these expressions in expanded form and see why we can't add terms when their exponents are the same. X plus 2x. Let's focus on that one first. X is just x plus, in expanded form, 2x is going to be x plus x. 2 x's added together. So I have x plus x. Over here, though, we have a little bit of a different story. Here we have all of our x's being added together. Here something else is going to happen. X obviously is just x, but x squared isn't going to be x plus x like it was over here. It's going to be x times x, like we saw before. So herein lies our difference. Over here, This all simplifies down to the fact that we have 3x's being added together, which we write as 3x. Over here, however, we have a little bit of a different situation. Here we only have addition, here we have addition, but then multiplication. We still see 3x's, however, they're bonded together in different ways. These two x's are bonded together through multiplication, and x times x can be simplified to x squared. And this x doesn't have anything else being added to it or multiplied to it, so x. Now we notice from here we get x plus x squared, which is the simplest we can go. And we'll notice that that's the exact same as what we started with up here. And that should make sense because what we said initially was that we cannot add terms unless their variables and exponents are the same. Here their exponents are not the same. This is why we cannot add them. X plus x times x is not the same as x plus x plus x. Problem 3. First thing we're going to do, write this down. First thing we're going to do is change the subtraction to plus negative. And then what we're going to do is we're going to look and see what we need to add. So what I would like you to do is pause the video, see if you can predict how many terms will be in the final answer. And if you can, see if you can predict what the final simplified expression would be. All right, I'm assuming you've paused the video. Let's take a look. So 4x squared. Let's see if we have any other x squareds in here that we can add with 4x squared. Nope. Here we have negative 2x, same variable, different exponent, so nope. Nope. Nothing else with an x squared on it, so 4x squared comes down. Now, I'm going to put these terms in order, but right now it doesn't matter what order you guys put them in. If you want to practice putting them in the correct order that we're going to use when we put polynomial expressions in order, we put them in what's called order from greatest degree to least degree. So my term that's actually going to come next is negative 2x. Carry that down. There's nothing else I can add with that negative 2x. So carry it down. Last thing I'm going to do, I'm going to combine what I have left. I've used 4x squared. I've used negative 2x. Those are both down. Now I am looking at this 3. Anything I can add with the 3? Yes. I can add the negative 9. Neither of them have an x on it. I can add them together. Negative 6. Final answer is 4x squared plus negative 2x plus negative 6. Problem 4. 2x minus 8x squared minus 3 minus 2x minus x squared. It looks scary, but we can change the subtraction to plus negative, and that looks less scary. And to make it look even less scary, we can take this negative x squared and we can do this crazy thing that we remember from before Thanksgiving, or I mean before Christmas break, where we put in our invisible 1. Cha. Now it looks a lot less scary. All right, let's add what we can add. Negative x squared, I can add that to my other term that has an x squared on it, negative 1x squared, so we've got negative 9x squared. Then, here I'm going to notice that I have, all right, negative 2x. What can I add that with? Positive 2x. Something crazy is going to happen. I have 2 negative x's and 2 positive x's. Oh, dang. Those guys cancel out. The last thing I have is negative 3. Nothing to add with it. He's just going to come down. Ta-da. That's all. Problem 5. This is a problem from the beginning of class. So let's simplify this. 5x squared plus 3x squared is going to give us, well, first let's look at this in expanded form. So write this question down again, and we're going to show the expanded form. 5x squared means that we have 5 sets of x squared added together. In other words, we have x squared plus x squared plus x squared plus x squared plus x squared. Now, if I wanted to, I can actually write this in like extreme expanded form. And I could do, instead of x squared plus x squared plus, I could do x times x plus x times x plus x times x plus x times x plus x times x. But I don't want to do that because that's a lot of typing. And I know you don't want to do that. So you can just leave it like that. Plus 3x squared, which would be 3 sets of x squared added together. And in total here, I have 8 sets of x squared added together. I have 8x squared. 4x in expanded form is 4x's added together. And I can add that with my 2x's added together. And in total, that's 6x's added together. And of course, 3 in expanded form is 1 plus 1 plus 1. All right, complete the following problems in the spot on problem 6 or anywhere else that you have space on your paper, front or back. Do those on your own. All right, I'm assuming that you've paused the video and tried these on your own. This first problem, this is going to be a negative 1x squared, and we can add that with 5x squared, and we can get 4x squared plus negative 3x. So your final answer here should be 4x squared plus negative 3x. Your final answer for this blue one, here we have negative 1x, positive 1x. Our x's are going to cancel out. All I'm going to be left with is negative 3x squared plus 8. That's all.